The third activity in the Jump Up for Math module is Legendary Leapers. Your students will jump as far as they can, record their distance, and compare their distances with those of other animals. Before jumping in, let's gather some materials and prep a good jumping track for our students to use. The materials we'll need are tape measures or yardsticks, masking tape, graph paper, chart paper, a good flat space to jump, the animal jumping distance table, and the animal body length jumping table. Make sure that you have at least one of these charts per student. You can find them on pages 14 and 15 of the Jump Up for Math module. To make our 10-foot long jumping track, we'll place masking tape on a floor in a 10-foot long straight line, with a 5-foot long piece of masking tape perpendicular to this, creating a capital T shape. Once this is done, mark off 1-foot increments along the 10-foot strip. When selecting your area, be mindful that your students will actually be using this track to jump, so make sure there aren't any odd bumps or hazards they could collide with and potentially injure themselves. Before we have the students jump to some conclusions, we want them to bounce ideas around as a group. This makes good mental connections between the activity they're about to do and what they have already observed in the natural world. Discussion gets them thinking observationally, like scientists. So ask your students to list some ways animals move: running, swimming, flying, soaring, gliding, slithering, crawling, walking, etc. Give them time to think and take a few answers. You could also have them act it out. It could be a fun way to get the wiggles out before the activity starts. Once they have a chance to answer, tell the class that you'll be learning about animals that jump. What animals can you think of that are good jumpers? How do you think that your jumping skills might compare? Once you're done with the discussion, it's time to jump. Line your students up along the 5-foot strip of masking tape. This will be the start line. Pick 2 students to be spotters along the 10-foot strip, ready with pencils, paper, and a ruler. It's a good idea to rotate these out so that every student has a turn. When your spotters are in place and ready, have students jump as far as they can, one by one, starting from a crouching position. As a team, the spotters will record how far each student jumps. Once everyone has had a chance to jump, let your students compare the distance they jumped to the animals on the animal jumping distance table. Which animal can they out-jump? Ask your students, do you think how tall you are affects how far you can jump? Give them some time to think, and then test this idea. Divide your class into pairs and have them use tape measures to find their height in feet. Write this number down. Depending on the age of your students, it may be a good idea for you to demonstrate this with a volunteer first. Remember the scatter graph from the last activity? Well, we're going to make one with the data you have just collected for this activity as well. On a big piece of chart paper, label the horizontal, or x-axis, student height. Then label the vertical, or y-axis, long jump distance. Help your students place a colored dot on the chart where their height and long jump distance meet. Can they see a relationship? How many students were able to jump farther than their body length? Was anyone able to jump twice as far as they are tall? That's 2 times their body length. Do you think there's a relationship between how big an animal is and how far it can jump? I wonder how far a grasshopper could jump if it were as big as a person. Now hand out the animal body length jumping table, and using a whiteboard, chalkboard, or a large piece of paper, demonstrate the following calculation with the entire group. A grasshopper is tiny, about 1 inch long. Compare this to a human that's 6'2", or 72 inches. To compare the jump of the grasshopper to this person, you would multiply 74 times 30 inches, which gives us 2,220 inches, or 61 yards. Okay, so a football field is 100 yards, which equals 300 feet, or 3,600 inches. In other words, a person-sized grasshopper would be able to jump more than half a football field in one single jump. Wow! If you'd like, show off one more example. A rocket frog can leap 6.5 feet. That's 35 times its own length, which is equivalent to a 6-foot human making a 105-foot long jump. Now, split your class into small groups to try to calculate human-sized long jumps from all of the different animals listed on the sheet. The students will be measuring from their own height in inches, so have them convert their height as a group. Now, refer to the animal body length table. For your students to accurately measure how far a critter would jump if it were their size, have them multiply their height in inches and the ratio of body length compared to length of jump. For example, I stand roughly 66 inches. If I happened across a 66-inch red kangaroo and challenged her to a jumping competition, she would jump my height, 66 inches, times her ratio of body length compared to length of jump, which is 10. That would mean she would jump 660 inches, or 55 feet. That's maybe a few feet farther than I can jump, so I'd probably lose, but not by much. Prompt each of your groups to share their findings with the class. Have each student explain their reasoning and how they worked out their calculations. You know, it's okay if the student did not finish the calculation or wasn't able to do it correctly. Instead, let them tell the group what they tried. Ask the group to listen respectfully. Did each group approach the problem in the same way? What kinds of answers did the group get? Which answers made the most sense, and why? Which one of the legendary leapers had the most surprising distance?
Changing the Equation, after-school math curriculum brought to you by Explora. Funding provided by Sandia National Laboratories. Find more Changing the Equation videos at explora.us/changing-the-equation.